Now, the first principle approach serves as the basic or the fundamental method of solving the differential calculus. So we can have a general representation of how to deal with any question that you have to solve using the differential calculus principle. So the general method or the general approach to deal with differentiation of any function is called power rule. There is what we call power rule. The power rule is a general method. It's a general method that is used in differentiating any function. It implies that when you have y to be as raised to the power n, any function y which is a function of s is having a coefficient a and a power n. I want to differentiate it, which can be the y, the x, or in some cases, because y is a function of x, it can also be f prime of x, because y is a function of x, because you can also have y as a function of x. If you have f prime of x, it's also talking about dy dx. So you can find this symbol in some other function also. Or if they don't want to use this, they can also use another notation, which is d as raised to the power n ds. So these are different notations to find the derivative of a function with respect to x. So, but I'm going to stick with the basic one, which is the y, the x, and that is differentiating a function means that what we have done in the first principle can be generalized in this power rule, and that is a times n, then s raised to the power n minus 1. What we have done is that the power that we have at the top of our independent variable will be brought down, will be used to multiply any coefficient. Then you always, after you have done the brought down, then you subtract it by 1. Then this is a n s raised to the power n minus 1. So this is general approach that we use in finding the derivative of any function. So let's deal with the derivative of, let's try to find the derivative of polynomial. I'm trying to give different examples that can occur. Let me just deal with these two examples, and I think that should settle what we are dealing with. So the first one, number 1, solution. The first one is I'm going to find my dy dx of this function. Anytime you have a polynomial and you are differentiating it, you have to differentiate each of the functions one after the other. This is d 2s squared dx plus d 3s dx plus d5 dx, and that means that you differentiate this one. I'm going to use the power rule, which is a more general rule. 2 times 2 is 4, s 2 minus 1 is 1, plus 1 is the power rule. 1 times 3 is 3, s 1 minus 1 0, plus, now this is differentiating a constant. A constant is having the power of that has to be 0. That's what the constant is having, because anything raised to the power 0 is 1 according to indices. So that's 5 times 0, s 0 minus 1. So it means that at the end of the day, when you differentiate the constant, your answer will be 0. If you look at this, is 0. So this is going to be 4x plus 3 plus 0, and that is your final answer. Very faster than the first principle. Then the second question, we are looking for the dy dx of this function. I'm just going to do it directly. This is 4 times 3 is 12, s raised to the power 4 minus 1, and that's 3. Minus 2 times 3 is 6, s raised to the power 3 minus 1 is 2. Minus 5 times minus 2, that's going to be plus 10, s raised to the power minus 2 minus 1, that's minus 3. Any other thing to be done? No. And that's all. You differentiated it. And that's what you get for this second one. Looking at it again to confirm, and that's what we get. So these two examples should explain the general rule that we just explained here when you are differentiating a polynomial function. Any polynomial function, you differentiate each of the entity of the polynomial function one after the other. We still have some other differentiation that we are going to delve into. Let's move on.